Once again, I am Sydney Jones, an engineer with Ecosystem Planning and Restoration. Wait, let me get my laser pointer. Can everyone see my screen?
Yep. And I can see the
Awesome.
laser pointer.
Wonderful. That's even better. My last presentation was focused on the SQT, but a very big update for the tool from version 1 to version 2 is how we deal with impacts. So talking about debits. So the picture on the left being impacted if you turn it into something that looks like the picture on the right. So why do we have two workbooks is the question I'm going to answer first. So the SQT, it measures functional uplift. So there's a change between an existing condition and a proposed condition. And then I'm really excited about our monitoring updates because, I mean, one of the big drivers of the SQT is here's your calculated change in condition, and then you verify it through monitoring. The SQT can also be used to measure functional loss. So if your proposed condition is worse than your existing condition, then the SQT will tell you there's lost function. There will be a negative value when you subtract the two numbers. So there is a loss. And in the version 1 Wyoming SQT, there was a worksheet that was the debit tool, and it still used the same condition assessments as that were in the quantification tool worksheet. Ahead of myself by a couple slides though. So um, when we're talking about debits and impacts, though, we are solidly in the 404 world. So if you're using the impact tool and you're not talking to the core, then I don't know why you're using the impact tool. Like the SQT is the better tool to use because the debit tool is specifically for calculating debits. So the credit is a unit of measure that represents the uplift of pre and post conditions and is verified through monitoring. A debit is also a unit of measure that represents the loss at a project site from an impact activity. So the Wyoming Stream Impact Tool estimates the functional loss, and it is most applicable to third-party mitigation. So this is where you are impacting a site, maybe putting in a roadway and impacting a lot of different streams for short lengths, and you're not going to do on-site or permittee responsible mitigation. You are going to yield some number of debits, and then you're going to have to go off-site to get credits to offset those losses. So that is the world that this debit tool was made for, where you are assessing debits at one site and the credits are going to be provided by a different site. For conversations such as permittee responsible mitigation or to determine whether there is a net loss for the particular project that might be working in a stream, the SQT is the tool you'll want to use. It is the better tool for that purpose than the debit tool. What is the challenge with impacts? So if I'm just installing a culvert or many culverts, as I put in a brand new roadway going someplace, there's not a lot of monitoring that goes on with the culverts, and particularly not looking at the responses of the upstream reach of the culvert and the downstream reach. So there's just not a way to verify that proposed condition score or monitor the impacts of what has occurred. Um, everything, most things I'm going to talk about today, like the Stream Impact Tool, is an extension and adaptation. Like the first process we went through back in 2017 is outlined in detail in a white paper that's available on Will's website, so the Stream Mechanics website, and hopefully the links are clickable when you get there. And that's the publication we point to when we're talking about how we develop debit tools, including the Wyoming Stream Impact Tool. All right, now I'm into the part of the presentation of the Wyoming Stream Impact Tool. So first of all, This slide says in big red letters, debit calculator. The debit calculator is a dead name for this worksheet, and the new name is the Stream Impact Tool, or the SIT, or usually prefaced with the W for Wyoming. And that's because the actual number of debits, as Paige will outline in her regulatory or her SMP presentation at the end of today, it might have other factors contributing to it. So what the impact tool is actually doing is calculating the amount of functional loss. It is not calculating the final number of debits that result from a site. There are other calculations that likely go into that one. So when you are impacting a stream, say taking something that looks like the stream on the left and turning it into the stream on the right, the impact tool does the same math as the stream quantification tool. So if the existing condition score is 0.5 for the stream shown and the existing length is 3,000 feet, the product of those two values is your functional feet for that stream reach. Once you've impacted it, if the proposed condition score is 0.3 and the proposed stream length, it's been shortened, it's been channelized, is now 2,700 feet, then the product of those two numbers is 810 functional feet. So when you do the subtraction for the change in functional feet for this project, you come up with a negative number. So this stream will lose 690 functional feet. It is now a separate workbook instead of being encased in the SQT workbook as it was in version 1. And it models the proposed condition score using impact severity tiers. The proposed condition data is not always needed. And I will talk more about impact severity tiers in a couple of slides. The proposed condition score and length results in a functional foot output that communicates loss in the same way that the stream quantification tool communicates loss. I feel like I've already said this 3 times, but there's a new workbook. It's a separate workbook. It holds up to 10 impacted reaches, and this workbook has 6 worksheets. This is a not legible screenshot, but just to show you what it looked like in version 1 of the SQT. And then this is the functional loss summary table from the new stream impact stream impact tool. I'm just going to call it the SIT. To show kind of the updates and how it's come along. So we're gonna not step through all the worksheets, but we're gonna start our journey by stepping through the first 2 worksheets with the project summary worksheet. So similar to the SQT, the project summary worksheet asks you for some project identifying information. And that includes the project name. If there's a ID number, project ID number, or applicant number, please provide that on this spreadsheet. And then a project description. What is missing here is watershed, ecoregion, bioregion, and just understanding that some impact projects might be linear and spanning multiple ecoregions and bioregions. That aspect of impact projects was just considered different, and so we put that as a unique selection for each of the reaches in this workbook. I have highlighted in yellow this priority category. So this information, priority category, is required for scoring. And that's another one, just like keep tabs, keep a list of the terms that I am using and not defining yet, because I'll come back to all of them. The next spreadsheet, once you finish filling out the project summary worksheet, is the functional loss worksheet. And this one, it contains some data that's filled out from the project summary worksheet. And then it also, so you'll see priority category carried over, as did the reach ID. You're also going to need to tell it what impact assessment option you're going to use to assess that reach. And then that term that I said we'll talk about later, what impact severity tier is the activity performing. This will all make sense. Yes. when I put up this slide, all of the terms tie back to this table. So future iterations, I'll move this one up more, but your impact assessment options. So the main benefit, the benefit of using the debit tool instead of the SQT is that you have assessment options. So within the assessment manual in the SQT, we didn't talk about what was a detailed assessment versus a rapid assessment. But in the debit tool, it's all about these impact options. With one, we've named it assess everything. So if you have impact, or if you choose to do impact assessment option 1, you are going to assess everything. Similar to applying the SQT workbook, you will provide field values for all 4 functional categories to assess that stream. And you're also going to estimate the proposed condition for the parameters in all 4 functional categories. So how does the impact that you are going to do, how will it impact all of the field values measured by the SQT? Alternatively, if you come down to impact assessment option 3, this one is assess nothing. So you do not need to assess that stream channel. You can rely on a default score for the existing condition score. So if you do not assess that stream, we are going to assume that it is functioning. And then we're going to use the impact severity tiers to determine how much functional loss is going to happen at that stream. And then, as you can imagine, in between those options of assess everything and assess nothing is the option to assess some of the things. So in the assess some of the things options, you can select which parameters to measure to replace the default score. So if we assume everything is functioning and you're out at the site and you're like, well, this is an ag field and my riparian vegetation is clearly not functioning, you can choose to assess riparian vegetation as a parameter and enter those values to replace the default score. And then you can take the default score for the rest of the parameters, but you can select which parameters to replace with measured data. Similar to the assess nothing option, your proposed condition score for debit option 2 is going to be to use the impact severity tier to estimate the proposed condition. Ooh. Default scores are, it's listed here in the table and I have a slide on it. Couple that all these ideas are intertwined, so I'll try to introduce them coherently. But your default scores relate to that priority category that was selected on the project summary worksheet. All right, so this is another way to summarize the impact assessment options that are available in the tool. And this summary focuses on just the existing conditions. So for the existing conditions, you can assess you can assess parameters in all 4 of the functional categories. And you have to do that for existing and proposed. And this one is the most like using the Wyoming SQT for restoration. You're just applying the same method to calculate loss. Option 2, you're going to take standard scores for any parameters that are not assessed. And option 3 is you just take a standard score and you do not assess everything. The term standard score, I should be using the word priority category because you will use the priority category to determine your standard score. In the Wyoming SQT version 1, the default score was a 1. So if you did not assess anything, your default score is a 1, and you take your debits calculated from there. We always say, like, if a project or if a stream scores a 1, we're not entirely sure it's plausible. It's definitely possible to score a 1 for certain metrics and parameters and even functional categories, but it's probably going to be a very rare stream that ticks all of the boxes for all of the functional categories to score a 1. So we revisited that assumption in the Wyoming SQT version 2. And so we have 3 priority categories. There are outstanding waters, which are DEQ class 1 waters and other special resources. There's the standard score. So most folks, most projects, most everyone is going to be selecting standard as their priority category, and that is going to give you a default score of a 0.8. There's an exception score that is a little bit lower, so it is a 0.7, and it is used solely on a case-specific basis following consultation with the Corps of Engineers. All right, more on the debit options, and I apologize. I'm like tripping up. They are impact assessment options now, and I'm trying to switch it just to calling them options. So this is option 3. We're going to start at the bottom because it's the easiest, and we'll work toward complexity. So if you've selected option 3, which is the easiest option, I think everybody should use this option. It would just, less work for everybody. You take the existing condition score default, either the 0.9, 0.8, or 0.7. Most folks are going to have that standard score of a 0.8. It so the reason I was saying everyone should choose it is it does guarantee no net loss. So, and the reason most folks might not choose it is it will yield, in theory, more debits than the other assessment options, unless you are impacting a very high quality stream. If you are impacting a very high quality stream, then this assessment option would yield you a similar number of debits as the other impact options. We figure it's mostly applicable for small impacts where the cost benefit analysis of assessment just doesn't outweigh the cost of debits. You're going to estimate your proposed condition using impact severity tiers. Option 2, you are going to assess the existing condition for your selected parameters. You can use either rapid or detailed assessment methods. For your proposed condition, yet again, you're going to rely on the impact severity tiers. So there's no estimating of individual field values. With options 3 or 2, you're going to just select an impact severity tier and it'll calculate your proposed condition score. This one's best for large impacts, and it also helps. It says consultants with experience using the SQT because it helps to have that eye of what is a functioning riparian vegetation community look like using the SQT assessment methods. So is it worthwhile to assess it, or is it going to cost more to assess it than to take the default score? Option 1, you are going to use the rapid or detailed assessment methods for all 4 functional categories, including biology, including physicochemical. And the proposed condition score is going to predict the post-project conditions for all of the functional categories, and that includes biology and physicochemical. I'd say debit option 1 or impact assessment option 1 is kind of the one, like, it's not recommended. I mean, you can use the SQT instead if you're too far in the weeds. Oh, all right, the final term. Oh, I meant to make the hit list of the terms I was listing and not defining. There was impact assessment option, which we covered. There was priority category, which we covered. So the priority category is associated with the existing condition assessment that you choose, and the impact severity tiers are associated with the proposed condition assessment or the proposed condition score for an impacted reach. So remember that impact severity tiers are only applicable to options, impact assessment options 3 and 2, because the proposed condition is assessed with impact assessment option 1. So impact severity tiers focus on the impact to function-based parameters rather than the activity itself. Activities are examples, and we do include example activities in the user manual for each of the impact severity tiers, but the focus is really on the severity of whatever you are doing. How does that impact the functions in the SQT? So a small activity may yield a lower level tier, whereas that same activity, if it's on a larger scale, so if you only have, what's the regulatory minimum? So if I have 500 linear feet of riprap on a pretty large channel, that is less of an impact than if I have the same riprap, but if it runs 3,000 linear feet. That is more of an
Mhm.
impact. And the selection of the impact severity tier always relates back to the stream functions because you are using them to calculate how much functional loss is going to be calculated. So if you have an impact severity tier of 5, that was the NC State football stadium, you've just removed it. There is no stream left. You're going to have 100% loss of that stream, and your proposed condition score is going to be 0. If you have a impact severity tier of 4, then uh, you're going to have, let's see, moderate to severe impacts to most hydraulic and geomorphic functions that are likely to result in severe impacts to physicochemical and biological functions. So for an impact severity tier 4, we are going to calculate that 75% of the function, so 0.25 times the existing condition score, means that you are losing 75% of the function to calculate the proposed condition score. And if you were wondering where I looked off to read the descriptions for the different impact severity tiers, this table outlines the same information. So it doesn't have the multiplier in it because I think that term is a little confusing and it's easier to talk about the functional loss that is associated with each of the impact severity tiers. So if you have something that is tier 0, bioengineering, tow wood, something that's like a softer touch. There are no permanent impacts to any of the key function-based parameters. That's going to be tier 0, and there's going to be no loss associated with that function. Whereas, again, tier 5 is going to represent where you've removed all of the aquatic functions and it's not a stream channel or stream ecosystem anymore. From there, like from 0, no loss, up to 5, complete loss, the impact severity tiers are described by the severity and how many parameters, function-based parameters that are impacted by the project. So a tier 1 has just minor impacts to veg and lateral migration. Tier 2, you're looking at impacts to veg, lateral migration. Here you're actually getting into the stream channel, so impacts to bed form diversity and flow dynamics. For moderate to severe impacts, or sorry, for tier 3, we're looking at moderate to severe impacts, and we're just impacting more and more function-based parameters. And for tier 3 is where you get into impacting floodplain connectivity, because once you disconnect or further disconnect a stream from its floodplain, there are just a myriad of consequences when those lower frequency, higher velocity floods are contained within the channel and can't spread out anymore. So when you're impacting floodplain connectivity, that's going to put you into a tier 3 impact. And tier 3 is assigned 50% loss. Here are the example activities that yeah, and again, I will stress that these are example activities. So like tier 0 is bioengineering of the stream banks. When we were developing, or when the team was developing the multipliers for the different impact severity tiers, we do think of example activities, and particularly from the core, like what kind of impacts are they seeing, what have they seen, and how do those impact the function-based parameters in the tool. So when we're thinking about tier 1, we're primarily thinking about something bank stabilization or utility crossing where you're not actually touching, like you're just touching the stream bank and not necessarily the bed. And these are also going to be like shorter scale of projects, so shorter in length. Whereas tier 2 also lists utility crossing. Someone's going to be like, gosh, you put the same thing in 2 tiers. And I will say that is intentional because the focus is not on saying like all utility crossings are going to be this impact severity tier. The question is, how is your particular utility crossing going to impact stream functions? And how can you do the design in order to minimize impacts to stream functions? All right. I took a detour. So I had the list. There are 6 spreadsheets, or so, yeah, 6 worksheets within the SIT workbook. And we started at the project summary and we went to the functional loss. And then I had to talk about all of the terms associated with impacts. So hopefully, glad this is recorded and we can go back and revisit it. But everything is based on your impact assessment options. So the first selection you'll make is the impact assessment option on the functional loss summary worksheet, where you tell it how much data are you going to collect. Because if you tell it that your impact assessment option is 3, then that means there's no data to collect. You just need to provide a stream length for the existing and the proposed condition and an impact severity tier, and it's going to calculate the amount of loss. In order to determine the existing condition score, it does need to know what priority category your stream is, because the default scores vary based on your priority category. So there are again 3. There's outstanding, which has a default score of 0.9. There's standard, which is the one most folks should be using or will be using, which gets a default score of 0.8. And then the exception gets a score of 0.7. And then impact severity tier, which when I open the impact tool workbook, you'll see that if I select impact assessment option number 1, this cell will go blank because you do not need an impact severity tier with assessment option 1. You only need it with options 2 and 3 to tell it how much functional loss to calculate, because it is calculated by multiplying the existing condition score by the amount of functional loss. Yeah, so there are 6 worksheets. You only really need 2, because you can stop at the functional loss spreadsheet if you are not using options 1 and 2. If you are using option 2 for any of the stream reaches in the workbook, you're going to need to fill out the existing conditions worksheet. If you are using option 1 and only for impact assessment option 1, will you need to fill out the proposed conditions worksheet. There's also a flow alteration module for debits, which is exciting. It has a similar update as the rest of the tool, where it doesn't have space for monitoring. So the flow alteration module that's in the SQT workbook has a place for monitoring data, whereas the flow alteration module in the Wyoming SIT workbook does not have space for monitoring data, and instead you get 10 copies, so you can have up to 10 affected reaches by your project. And again, the reference curves are provided in this worksheet as well, so that if you're ever wondering how in the world this spreadsheet is scoring your value, those are there for your reference. And to wrap up the debit tool slide deck presentation, I wanted to highlight just some of the updates from version 1 to version 2. So the debit options from version 1, debit option 1 is the same, kind of assess everything. And in that case, you would have been using the actual SQT workbook. Debit option 2 in version 1 was the assess some things option, and it still used the impact severity tiers to calculate your proposed condition score. For your existing condition score, it had default score of 1, and it was applied at the category level rather than at the parameter level. So you have more options of what to assess and not to assess in version 2, whereas in version 1, you'd have to assess all of geomorphology rather than just individual geomorphology parameters. And then debit option 3 is the assess nothing option, which is the same between the two, with the exception that the default score has changed. So it was a 1, and now you have priority categories to select. This is just highlighting what I noted on the previous slide, like the change in default condition scores. So you can see here the default condition score of 1 applied at the functional category level in the version 1 of the worksheet. And then this is an excerpt from version 2, where you have default parameter scores instead of functional category scores. So this shows the parameters in reach hydrology and hydraulics applied with a standard priority category score of 0.8. And something fun in the impact severity tool workbook for existing conditions is it does have some built-in capabilities for parameter selection. So our recommendation is to use either base flow dynamics or bankful flow dynamics. So you'll see that only bankful flow dynamics has a default score. And if you enter data for base flow dynamics, the default score for bankful dynamics will go away so that it doesn't count against you. So you can replace this default score for bankful dynamics using either base flow or bankful dynamics. The impact severity tier options. I believe the example activities, I mean, we revised them and we added clarity to the language and example activities. And the biggest edit was really instead of just saying impacts to riparian vegetation and lateral migration, we added a severity term. So whether or not those impacts are considered minor or whether they're considered moderate to severe impacts. And that's consistent through all of the impact severity tier descriptions, is just adding those qualifiers. There are still the same number of impact severity tiers. And this is a side-by-side just to show the changes, the updates in the what we're calling the impact factors, or I think they were called multipliers in the version 1. But side by side is the functional loss. So you'll notice that the percent loss is 1 minus the impact factor. So there are slight changes, and I think the biggest change is going to be that in the version 1 tool, there for impact severity tiers 1, 2, and 3, there was a special exception where it was only looking at reach hydrology, hydraulics, and geomorphology, and it was not looking at the entire rolled up condition score. And so there's no longer kind of an asterisk on these multipliers where they don't apply to the whole reach score. All the multipliers for the version 2 apply to the whole reach score. And gosh, I tried so many language ways. Words are hard as it gets later in the day. Words and tables to kind of explain this idea of like the impact factor versus multiplier. I'll end it there. That's all right. The last slide in this presentation is that stay tuned because Paige is going to follow with an SMP presentation. And I hope I didn't just scare Paige because I do have another presentation between here, but I don't think I have time for questions. But I need to switch over.
At one point there was a hand raised, but then I think the hand went down. So I don't know if the question got answered or not.
Or I just confused them more.
All right, I guess we're good.
It could be an accidental hand raise. Those happen sometimes when you're like looking for a laugh button.
It might have been.
All right. Check in on the schedule. Oh, I still have 10 minutes. Man, that's all right. I wanted more time for this presentation anyway. My next presentation is the tour of the user manual, forms, and updates. But I'm going to take advantage of the fact that I just gave a stream impact tool presentation. I think this is the first time I've said that these terms like aloud so many times. So the stream impact tool presentation to show you some capabilities in the stream impact tool workbook. So let's see. Both workbooks start with the project summary worksheet that's going to provide roll up scoring. So in this case, you're going to get a total functional loss number, and it's up here at the top, and it'll sum all of the results from the functional loss summary table on the functional loss spreadsheet, and also all of the results from the flow alteration module worksheet that are in this workbook. You can insert your applicant name, permit ID, project description. Down here, you want to make sure you are identifying your flow type and Strehler stream order. And again, these are attached to the scores for individual reaches. So anytime you see a delta, you'll see what flow type and stream order that score is associated with, and that just helps prevent out-of-kind mitigation. Similarly, there's a box to describe the impact and reach break criteria. Unlike the reach break criteria presentation from earlier, for instance, linear projects would not have the same reach break criteria. So if you're just crossing a stream, then you have a very distinct reach break within your right of way or for the footprint of the culvert that you are installing. So just making it clear, like if, you know, how you've determined the reach breaks and defined the different reaches in this tool as well. And the most important input on the project summary tab is going to be this priority category, as that relates to your default scoring. Same information is requested for the flow alteration module. So stream ID, well, this would be the affected stream reach rather than the stream reach defined for the reach scale condition assessment. And then come over to the functional loss worksheet, and it carries over the name, date, applicant. And this is the power table. This is the, like, if there was everything this spreadsheet is made to do is summed up like in this table, and it calculates your total change in functional feet. From the reach scale assessments on this worksheet and in this table. Everything else on this particular worksheet is just to help you understand what this table is doing. So it's providing you with the stream reach and priority category that you already entered. And then we have the impact assessment options. So impact assessment options primarily relate to how you're going to collect or assess the existing condition. So for impact assessment option, we'll start with the easy one, 3. So if I have an impact assessment option 3, I do not need to give it any information other than an existing stream length, a proposed stream length, a priority category, and then an impact severity tier. So in the case of a tier 5 impact, that's where I've removed all aquatic function. My proposed condition score is 0. My existing condition score, because this one was identified as an outstanding water, is 0.9. So it has multiplied 0.9 times 100. And then the proposed condition score is 0 times the same stream reach. I could change that length to 100 or to 0 as well. And it is calculated the change as -90 functional feet for this perennial third order stream. I do not have to enter any data at all if I have chosen to do impact assessment option 3. Easy, I'm done. If I assess all of my reaches using impact assessment option 3, I just have to fill out this part of the table and I'm done. If, however, I am, make that one 1,000 instead. If for reach 2, I have it as reach ID example 2, this one's going to be a standard priority category, and I've chosen to assess some things in this one, so I have to give it my existing and proposed stream length, and then it is automatically populated an existing condition score of 0.8, but because I told it I was using impact assessment option 2, I need to come over and fill in any field values of the data that I have collected. And to stick with the example I had earlier, so if I look at that stream reach and I'm like, gosh, you know what, bankful dynamics or flow dynamics in that reach are really messed up, and I think it'll score a 0 for flow dynamics. rather than accepting this condition score of 0.8, I can come in and I go out and collect the data and measure it, and I get a field value of 1.9 for my Bankful Dynamics parameter. I can replace that value and it will overwrite the default condition score. If instead I have measured base flow dynamics, I'm gonna make up some numbers. Ooh. All right, I won't make up numbers. I hadn't test run that one on live. That one is stratified by, it might be a temperature tier. But it would replace, did it replace it when I did it? No, it would replace the default score for Bankful Flow Dynamics because these are implemented as an either or selection. You'll see that the other, what are considered optional, I don't think of them as optional, more so as like recommended when. So for large woody debris, like where it is applicable, you should provide a value for large woody debris. And so let's say I can go out there and pretty easily assess that I have no wood in that channel. I can come in, do my piece count and say there's no wood in that channel, put it in, and it'll score in combination with the default scores for the metric. There is an abbreviated site information and reference selection section, and it is organized differently from the SQT, just so that we can keep it associated with the reach on top of it. It is important to note in using this worksheet that my reach ID is automatically populated. So when I came in to the existing condition spreadsheet, I have to find which reach ID to enter data for. So the third condition assessment down has my example reach ID. And then you'll see that the others are not populated because I haven't told them I did not enter any data for those reach IDs. So if I come in here and in my fourth entry down, I enter that this, actually let's call it, my fourth entry down is going to be for a trib, so UT1. I have to enter my data for UT1 into the correct condition assessment in the impact tool workbook. And similarly, if I have selected, so for example stream 3, I did select impact assessment option 1, which is the assess everything option. So I would need to come in to the existing conditions worksheet and fill out all of the site information and reference selection data and all of the field values to assess all 4 functional categories. And as I fill out that data, it's going to automatically populate on the proposed condition spreadsheet so that the existing and the proposed are pulling from the same data to calculate the reference curve values. So they didn't populate for example stream 1 or example stream 2, but if I scroll down until I find the right one, I had just told it that example stream 3 was a C stream type with a stream slope of 1 in an unconfined alluvial valley. So that data carries over into the proposed condition spreadsheet. Oh, to note, there are no longer 4 stream types required in the debit tool, the impact assessment tool. There's only one. You only need the stream type that is associated with scoring. Because there is not a design process for how you are benefiting stream functions or restoring stream functions, you just need the information here that is required for scoring. And you'll see the same like ugly black box that is related to the volcanic scoring for percent riffle. And that gives you an option when you have an option to select your reference curve. So if you're in the volcanics ecoregion and your stream slope is less than 1.3, you have a choice you can make between reference curves for your project. All right, all the other items on my list I have talked about, so we are going to abandon the impact tool